Hello, in this video we will be going over how to safely perform batch distillation using a bevel plate column. Distillation is one of the most common separation processes. This will utilize differences in volatility or the tendency for a substance to evaporate. The larger the difference in volatility, the easier it is to separate. Batch distillation is easy for small quantities. As you can see in figure 1, the vapor boils up the column coming from the reboiler, and the liquid condenses from the condenser and flows back to the column or is taken off as distillate, depending on the reflux ratio. Theories used in this experiment are steady state, in which the conditions in the column are not changing, equimolar flow assumption, in which the vapor going up the column and the liquid flowing down the column are constant. Also, we will use the McKeel-Thiele method in determining the number of theoretical stages in the column. The objective of this experiment is to separate the ethanol from water using the bubble plate distillation column at 0 to 100% reflux. The boil-up rate and the compositions of the distillate at 50% reflux will be determined. Now to the equipment used. The reboiler is used to heat the ethanol and water mixture. A column is also used. This has plates inside to ensure that the vapor mixture reaches equilibrium. The column pressure is set to 1 atm. The condenser or the chiller is used to condense the vapor. This can be adjusted to be a partial or total condenser by turning the valve. The liquid sent back to the column is known as the reflux, and the liquid going out is known as the distillate. Also uses a refractive meter to determine the refractive index, which can later be used to find the mole percent. This is used by placing a small drop in place and looking into the eyepiece for a distinct white line. Ensure that the glass is clear of debris before use.
The major components of the procedure are to calibrate the refractometer, run the column at total reflux, determine the boil-up rate, run the column at 50% reflux, and analyze the results. Calibration is done so you can identify compositions of samples taken later on in the lab. The samples are to be made of known compositions by mixing ethanol and water to the percentages in the second bullet point. To then obtain the refractive index, use a small syringe to extract a few drops of each sample and place them in the well of the refractometer. A sample graph of the calibration curve of an ethanol water system is shown in the slides. It is important for all the samples to make sure they are covered so that there is no vapor loss. For the next portion of the lab, it is important to determine the expected boiling point of an ethanol water system that is 30% ethanol by volume. The pot shown in the video is approximately 30% by volume ethanol. If it is not clear, make sure to notify an instructor or TA. First, start by taking a sample from the pot to determine the amount of ethanol in the system before the reboilers turn on. Then, make sure the chiller is on and that coolant is recirculating. Close the distillate to run the system at total reflux, meaning that all the ethanol that has evaporated up through the column will condense and 100% will return to the reboiler. Turn the reboiler on to 80% and 120 volts. If the temperature rises above the expected boiling point with no bubbles forming, make sure to notify TA or instructor because this could be a sign that the system is superheating, which can cause bumping of the distillation column. Run the system until steady state is reached. This can be determined by there being a less than 1% change in the temperature of the top and the bottom. Then collect samples from both pot and condenser. Make sure that you flush the exit port of any liquid left over from the past before taking the sample. Make sure all samples are covered and let them cool to room temperature before measuring in the refractometer. Wait 10 minutes and then collect these samples again to verify the steady state. To determine the boil-up rate, close the reflux valve and let condensate collect in the accumulator. Record the volume every 1 minute. The boil-up rate can then be determined by the total volume over the total time collected. Stop after 15 minutes or if the accumulator is half full. To set a 50% reflux, open the reflux valve so that 50% is returned to the column and the other 50% is removed as distillate. Make sure to do this slowly so that you do not damage the equipment by adding cold liquid into the hot column too quickly. Then collect the distillate and record the volume as a function of time by taking readings every 5 minutes. Make sure to note the bottom and top temperatures every minute and stop after there's a measurable change in the top temperature. You should have collected about 100 to 150 milliliters. Do not collect more than this, as there could be too much ethanol leaving your system. Also, do not discard the distillate. Once it is cooled, it will be returned back to the system. Analyzing the results. Create the calibration curve to determine the mole percentage of ethanol collected from the pot and the condenser at steady state. Construct a McCabe-Thiele diagram to calculate the theoretical number of stages, or plates. Analyze the efficiency of the column by comparing the theoretical number of stages to the actual number of stages. Error in this lab can come from not cleaning the refractometer, assuming a 30% volume ethanol in the system, and assuming that there is constant composition and no liquid holdup. Proper PPE of goggles, a lab coat, and gloves are required for this lab. The heater and coils are a burn safety hazard. Bumping is also a safety hazard. This is when a system superheats and a large vapor bubble is rapidly released from the system. This can cause the equipment to explode and liquid to be released. Ethanol is flammable and can cause skin and eye irritation. If ingested, it can cause internal organ damage. It is important to dispose of all waste in the proper receptacles during this lab.